Today we are going to start with quicksort algorithm. So like what is quicksort, right? So basically it is like a sorting technique which sorts the element in decreasing as well as non-decreasing order. It is up to like us or how we formulate it. So the positive point of that is like it takes, so the time complexity which required to solve a quicksort is big of log n log n log n. So moving straight up to the point. So how we are going to formulate quicksort, right? So it is nothing like we just need to like take the pivot. So like pivot, we take pivot as like pivot the first element, and we will divide both of the arrays according to this pivot. I think this is a bad example. Let me take another one. Let me take the other one. Suppose take as 2 minus 9 10 100 7 96. Let's take one 8. Yeah, it is perfect. So yeah, this is perfect. So what we are going to do is we are taking to take the pivot as the first element, and then we are going to divide the arrays according to this first pivot. So like if the element is less than 2, then it is going to be on the left side like this half, and if it is going to be like greater than 2, then it is going to be on the right hand side. So like if you can see, then this is going to be on the left, and we are going to achieve minus 9 and wait a minute, and on the left we are going to get 10 100 6 and 8. So we are going to get 10 100 and 6 and 8, right? And then we are going to traverse it again back again, like since like there is nothing to like divide it. So we will in this pivot, and we will see like if it is like pointing, like we will divide it into more two parts, where we can see like it is 6 8, and there comes 100. Similarly we will take this, and we are seeing like there is nothing to sort about. So we will retrace it, and it will be like 6 8 10 and 100. And suppose like this is we will not stop until unless we get only one element on the each on the both side, only one element, right? So what we are going to do is like we are going to retrace it, and we will be seeing this as a final output. Let me change the font. change the final. Yes. So like the final answer would be 0, 2, 6, 8, 10, 10, 100. Like since it is like just this is like just the left half, this is like the right half, so we are just going to merge these two and put 2 in the middle. Like same things happen with 10 also, like we have just put this and this and we have just merged it. So like we are going to do this. So let's get back to the coding part. Here we would be logically dividing the arrays into left and right side according to like if the first element, the elements which are less than first would be on the left side, and elements on which is higher than the first pivot element would be on the right side. So like first we have to divide, like I'm writing the code logic for dividing, right? So it would be the term like if this is the base condition, like if low is greater than high, then it is less than it means this means like there is no element to short. So it will this function will basically partition do the partitioning work, and since like suppose we have done like this, like we have achieved this, right? Like suppose like after like this goes on, this does the partitioning work, and like we have to divide it again and again. So we have to like recursively call the function again and again to see and to repeatedly like shorting the arrays. So that's the catch. Minus 1. Yeah, right. 1 plus 1. So that's it. That was the code for this. And for the partitioning, we have to keep putting we are taking the first element as low, then we would be creating two array list. So we cannot do it like that, right? We cannot traverse it like that. It would be I equals to wait a minute, check. So this is the case, like I'm just seeing like, yeah, since like there is n minus 1, so I can use this. I can make it I equals to, yeah, this would work. So if the value in the array is less than pivot, and yeah, one we need to take, like we need to eliminate this, the first value also, like since we are not including this value in our comparison. Then we would do add, else we would be adding the element to the right side if it is greater than that. If it is greater than that, okay. So like we cannot return this, so we have to like store it into the array itself. So here we are storing storing the value over here, and array we can go like just traverse it like that, and so like where we are, yeah. So like what we are going to do is we are just going to append it on the basis of like this. Suppose we are going to take another integer and it would be as right. So what we are just doing, like we are just storing the value right over here, and PARR, and after storing all the values we are going to do this. We are going to store the pivot value, and then we are going to repeat same for the right sub array. Right, and we need to like return. So what would be the answer? Like it would be left dot size. I guess this should work. I guess this should work. I hope this works. Compile error, compile time error. Okay. Quick shot. Some typo errors are there. But yeah. So it should be low. It should be low. And I think that we are good to go. I hope this works. Yeah, it worked. Yes.